This question comes from Max, who asks, what if we turn Jupiter into a giant fusion reactor? Max, buckle up, because we're about to make the biggest power plant in the solar system, and it's not even on Earth. Jupiter, the gas giant, is already massive, more than 300 times the mass of our planet, and mostly hydrogen and helium, which makes it perfect fuel for fusion. Imagine harnessing that energy, basically the ultimate cosmic battery.
First, let's consider the scale. Jupiter contains more than 1,300 times the volume of Earth. If we somehow ignited controlled fusion throughout its core, we'd be talking about producing energy equivalent to millions of suns in a single object.
Max, the stormy red spot would practically become a neon sign screaming, "Power on!" But there's a catch. Fusion requires extreme temperature and pressure.
Jupiter already has high pressure in its core, but we'd have to fine-tune it carefully. Too much, and we risk triggering, well, something between a supernova and a very bad day.
Now, what would happen to our solar system? Jupiter is the gravitational giant keeping asteroids in check. Turning it into a massive energy generator would change its mass distribution slightly, which could subtly shift the orbits of moons, asteroids, and maybe even Earth.
Max, your next eclipse might be a little off schedule, but that's just the start. Jupiter's new fusion power would emit an enormous amount of radiation.
Satellites in its vicinity? Toasted! Space probes? Toasted! And if you were foolish enough to be on one of its moons, say Europa, you'd be getting a very close sunburn from a mini-star in your backyard. Let's talk energy harvesting. If we could extract just a fraction of that fusion output, Earth's energy problems would vanish overnight. No more fossil fuels, no more blackouts, and even electric cars would start to feel guilty about how much power they draw.
Max, basically every energy dream you've ever had would come true. But there's a dark side. Containing fusion energy on Jupiter isn't like building a power plant in Arizona. It's more like trying to bottle lightning, a hurricane, and a sun all at once.
The radiation is another fun problem. Fusion produces massive amounts of high-energy particles. Jupiter already has a strong magnetic field, but turning it into a reactor would amplify that field drastically.
Auroras? Incredible! Satellites? Dead. Space tourism? Forget it! Max, you could light up the solar system like a cosmic disco ball, but your Wi-Fi would probably be toast across 3 planets. And then there's the moons. Jupiter has over 90 of them, each with their own environments. Io would probably start to boil under increased heat. Europa might thaw too much for its icy oceans. And Ganymede? Well, Max, let's just say it wouldn't be a peaceful getaway anymore. The tidal forces from a fusion-powered Jupiter could trigger massive geological activity on all the moons, turning them into mini volcano worlds.
The question of runaway reactions is also important. Fusion is tricky. If containment fails, the output skyrockets. Jupiter isn't a planet we can just encase in steel walls. Max, the stakes are literally planetary.
A failed experiment might turn Jupiter into a nova-like object, which could affect Earth's climate, radiation levels, and maybe even orbit stability. On the other hand, with perfect control, we'd have a clean, nearly infinite energy source without burning a single fossil fuel. Now, let's imagine the practical benefits. Space travel? Easy. Powering colonies on Mars? Done. Sending probes to the outer solar system?
Laughably simple. Max, you could make Star Trek look like a budget sci-fi project. And if we ever wanted to engineer weather on Earth, or even control the tides, a fusion Jupiter would give us the ultimate leverage. But we'd need super advanced tech to harness it without frying ourselves or the moons. In conclusion, Max, turning Jupiter into a giant fusion reactor is a perfect example of awesome in theory, terrifying in practice. We'd solve every energy problem, power the solar system, and unlock space exploration like never before. But we'd also be juggling gravity, radiation, and planetary-scale nuclear reactions.
One wrong calculation, and Jupiter stops being a giant power plant and starts being a very expensive interplanetary hazard. So for now, maybe just admire the gas giant from Earth and leave fusion experiments to our labs, much smaller, much safer, and way less likely to start an interplanetary incident. P.S. Max, if anyone asks whether Jupiter is on tonight, just smile and say yes, but maybe don't tell them it's nuclear-powered. Some things are better left as imagination. For now.